to straight ahead calculate what's the probability of not getting, or of getting just one or more reds, so at least one. Rather than calculating at least one red, what I'm going to do is I'm going to calculate what are the chances of I don't get any reds. What is the chance of me not getting any reds whatsoever? So rather than doing what they ask me, I'm going to do the complete opposite. It says at least one. I'm going to say, what are the chances of me not getting any? So that's what I'm going to do right now. The probability, that's really tiny. I have a hard time seeing if I don't have anything else on here. It's just like a big whiteboard. Is that bigger? There we go. So the probability of no reds. I'm not going to get any reds at all. So what's the probability of my first card not being, was it card or marble? I don't know, marble. It'd make more sense because we don't have red cards, blue cards. But what's the probability of my first card not being red? I said it again. Good thing I'm recording this one. We're talking about marbles here. So I have 5 red marbles, 3 yellow marbles. I have 4 blue marbles. So that means there's a total of 12 marbles. So the chance of it not being red would mean that I need to either pull a yellow or a blue. So we have 7 that aren't red out of my 12 marbles. So my first marble not being red would be 7 out of 12. That is, I didn't pull a red. Now, I want to say, I don't want my next one to be red either. My next one's not going to be red either. Well, we're not doing replacement. So I no longer have 7 that aren't red. I now have 6 that aren't red in the bag. Out of 11. Perfect. And when I do this multiplication and I simplify, I'm going to come up with, we have 7 out of 22. That is the probability I don't get any reds. Probability of no red. We'll say marbles, but we'll think cards because that's what I'm thinking today. But marbles. There's 7 out of 22 is the probability of absolutely no reds. That wasn't the question, right? The question was, what is the probability of getting at least one red? Well, if this is the probability of getting no reds, then the probability of getting at least one red must be kind of, and it's we're going to learn today, it's called the complement. It'd be 15 over 22 is the probability we get at least one. At least one red. Does that logic make sense? Okay, awesome, because that's what we're going to talk about today. Any questions on this one? All right. Well, yeah.
How'd you get 15?
I got 15 because 7 out of 22 are no reds. So 15 out of 22 must be at least 1 because 15 plus 7 equals 22. That's 100%. All right. If I kept it in the full, we could actually talk about the total marbles that you pull. But in short, whatever gets me to 22 is going to be the probability at least one red. So it's just from 7 plus 15. We'll talk more about that later, too. This is a big concept we're going to talk about today. All right, Jack. He's got a kill done. The text on number 12, awesome.
How does one go about placing a number in a vowel?
Yeah,
Oh my gosh, that was so funny.
Yeah, I was.
You get like an animal that's already dead, and you stuff it, and then you put it in the bowels of the animal.
Okay.
All right, good. All right, yeah.
Okay, I got so like.
Let me mark that so I can change it.
Vowels. Okay. I got so like confused on number 11.
Cool.
Because I did it one way originally, and the answer said it was wrong. And I looked at the answer, and I'm like, oh, that makes sense, because you did like 52, choose 5. And I'm like, because we're picking 5. But
Yep.
my friend was like, wait a minute, that won't work, because that would be like, that's how many combinations there are, isn't it? Wouldn't it be like 1 over 52 times like 1 over 51 times?
No. Think about this. So what you're talking about is permutation versus combination.
Yeah.
Your friend does not understand the difference between combination and permutation. If we did 52 times 51 times 50 times 49 times 48, that is a permutation.
Oh, because it's in order.
That's a specific order. So if you use 52 times 51 times 50, that would say if I got an ace, king, jack, queen, that's different than getting a queen, king, ace, jack. But in cards, it doesn't matter what order I get them in, because as soon as you get cards, you kind of organize them how you want to as it is. So with cards, when you get a hand, order does not matter, so it has to be a combination. It has to be 52, choose 5 in a combination.
Okay, so if would the answer be?
I don't know what happened either. But yeah, continue.
Be 1 over 2,598,960?
Yes.
Okay.
Because there's only one hand that would be the ace of hearts, king of hearts. I think I used hearts. Jack of hearts, king. There's only one hand that has that.
Yeah.
If order mattered, it'd be a completely different problem where it would be 52 times 50, and we'd have more possibilities on the top. Because that would mean that if I got the ace of hearts first and king of hearts, that'd be different than getting the king of hearts, ace of hearts first.
Yeah.
But order does not matter, so you have one hand that has that, and it's a combination problem.
Those are all possible hands.
Yes.
Okay.
Always think hands in like poker or something like that, those are combination problems. Anything with cards is basically combination if you need to get the total. Yeah, Juan.
For number 12, why is it like 1 over 11 times 8? Why is it an 8?
1 over 11 times 8. Because... So the numbers 4 through 14 are placed into a bowl and drawn at random, then replaced after being drawn. What is the probability of drawing the number 14? So the first probability is just me drawing one number, and that is the number 14. Let me take a picture of this real quick so we can see my bowl circled. Ugh, that sounds weird. All right, so the first thing I'm going to pull is a 14. There's only one 14 in that bowl. So it is 1 over 11, and that's because 4 through 14, 4, 5, 6, 7, 8, 9, 10, all the way up to 14 is 11 numbers. There are 11 numbers in this bowl. Then it says, what are the chances of getting a number that's less than 12? There are 8 numbers that are less than 12. That would be 11, 10, 9, 8, 7, 6, 5, 4. So that is 8 numbers less than 12. That's where the 8 came from. But it's with replacement, so we still have 11 cards. Yes?
If you got upset
Is this on the...
Yeah, it's about this.
Okay, yeah.
If one was upset with this problem, you may say they had ideas.
Okay, yes.
Go over 3.
Yes. Let us refocus. Okay, number 3. What is the probability of getting the same number on both dice? Dice? Wow. That's got to change too. I think I changed this one. And I just printed off. Okay, what is the probability that of getting the same number on both dice when when a pair of dice is rolled? In this example, we're looking at when are both numbers the same, and that's when you get a 1-1, a 2-2, a 3-3, a 4-4, a 5-5, or a 6-6, right? That's the only time I can roll 2 dice and it's the same number. So that means there are 6 outcomes that match that. And if I rolled two dice, that 6 times 6 would be 36, which then simplified, that's where it's just the 1 over 6. So I did have the 6 over 36 first, and then it turned out to. Other questions? Yeah.
8D.
8D. So 8D says at most 1 head. So on a problem like this, especially when it's just flipping 2 coins.
I just realized what I did.
Okay, well then never mind. Solve that problem. No bubbles involved there. Yes.
About 8D.
Well, I almost took the picture and then Juan made me not take it.
How rude.
8B, you said?
Yes.
All right, like I was starting to say, and then Juan shut me up. if I had a problem like this, I'd probably just because it's just 2 coins. It's really easy to write my entire space out here where it's head, 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 tail, tails, head, tails, tails. If I go here, it says at least 1 head. There is 1, 2, 3 that have at least 1 head. It's 3 out of 4. It just makes your life easier to draw that picture.
Okay.
Instead of trying to picture everything in your head, just write it out. Yes. Yes.
On a different problem.
Yes.
Okay. 90.
9D.
Oh, I wish you had like a
I thought you meant 9T. I was like, there's a 90 right here.
Number 9D.
Speak English next.
Letter 9, number D.
Okay, thank you. If a single die is rolled twice, then what is the possibility of getting no more than 2 4s? Let me change that question real quick.
You can only have 2.
No, it doesn't say that.
Yeah, I was
Let's get rid of the no real quick.
really weird.
What if I ask, what is the probability of getting more than 2 4s? So that means I have to get 3 4s to break it. There is a 0%. So no implies it's the opposite.
Oh.
It is basically, what's the probability of getting at most 2 4s? So 2 2s would work, because I said at most it can be 4 4s. The only thing that would break this is if I got 3 4s. So it has to be 100% chance. There is a 100% chance I will not get any more than 2 4s. That's what it's saying. What are the chances of getting no more than 2 4s? So a 1 and a 2 works because it's not more than 2 4s. Anything works in that with 2 die. The only thing I'll break is if I get 3 4s. Is that less murky? You can almost see through it. Okay, other questions real quick, because we got to get going.
I almost forgot that I brought my dice today.
Ooh. And with that in mind, we will start today's lesson. All right. Yesterday, and if you have your notes in front of you, turn to page something. Can I see yours real quick?
No.
No? Thank you.
Yeah, okay.
Thank you.
Oh, she changed her mind.
Turn to page 72.
That's the same thing.
Turn to page 72. It is not the same thing.
I was kidding.
That is compound event. What is the word that you wrote, or hopefully you wrote, somewhere around compound event? It's 3 letters. It starts with A and has a D at the end. And I'll let you fill in that middle.
N. Oh, and. I get the letter.
And tells you it's compound. What do we do with compound events? Do we multiply, subtract, divide? Yeah.
Multiply.
And tells you to multiply. Today we're talking about mutually exclusive and inclusive events. The big word attached to this one is going to be or. And if before I even get to anything else, or is going to tell you to add. All right, that's before I get to anything else. Or tells you to add and tells you to multiply them. And I'll tell you why it's different, why it's adding versus multiplying. So mutually exclusive and inclusive events. These are events that can occur at the same time. That's why we have or. I will teach this class or I will leave. I can't do both at the same time, so it can occur at the same time, but it replaces itself. So events that can occur in the same time are called mutually exclusive. They can occur at the same time. If 2 events are not mutually exclusive, they are called inclusive. They are called inclusive, and let me give you some examples down here. So first of all, we have probability of mutually exclusive events. That means these events can happen at the same time. Probably not the best definition, but once you see the example, it makes more sense. So if I could roll a 2 or a 3, either I roll a 2 or I roll a 3, they are not, you can kind of think of it as dependent, independent. They aren't dependent on each other. There is no overlap. Either I roll a 2 or I roll a 3. If I could roll a 2 or a 3, this is mutually exclusive And we have this little statement that the probability of A, or, that's what that symbol stands for, or the probability of B is just the probability of A plus the probability of B. The alternative is it's an inclusive event. It is an inclusive event. That would be me saying, what's the probability of picking a king or picking a heart? What makes it inclusive is that there's an element of overlap between those two categories. You could pull a king or a heart, or you could pull a king of hearts. There is overlap. If there's overlap, if there's an element that's shared by both categories, it is inclusive. 2 and 3 are distinct from each other. There is no 2 of 3. There is no, you can't do your die where it's cockeyed and you have a 2 and a 3 up. It is either a 2 or a 3, so it makes it mutually exclusive. If it's inclusive, what you're going to do is you're going to find the probability of A, you're going to add the probability of B, and then you're going to subtract that overlap. If you do not subtract that overlap, what you're basically accounting for is a king of hearts here and a king of hearts here. You accounted for it twice. You need to eliminate one of those because you can't count something twice. So when it's inclusive, you're trying to get rid of that overlap so you don't count something twice. Let's just go ahead and just do an example or 2 examples so we can see the big difference. All right, a card is drawn from a standard deck of playing cards, so that's 52 cards. Find the probability of drawing a king or a queen. Let's go back to our thing. Is that going to be exclusive or inclusive? Yes?
Exclusive. Mutually exclusive.
Yep, it's going to be exclusive. I'm just going to say exclusive. That's fine. We know we're all talking about the same thing, so I'm just going to put exclusive, but it is mutually exclusive. And I think I put, what did I put for my reasoning? Put something to the effect that no king can be a queen or something. So either it's a king or it's a queen. It can't be both. How did I put it? Either it's a king or a queen. Either it's a K or Q. Should really be an A there, but I ran out of room, so we'll just put a king or Q. If it's exclusive, we are going to find the probability of pulling a king or the probability of pulling a queen. The probability of pulling a king would be 4 out of 52. Or a queen would be 4 over 52. And that or tells me to add them. And once we add them, we get 8 out of 52. But 4 goes into 8, and 4 also goes into 52. So that's going to be 2 over 13. And let's talk about that power of or and how I know it's adding. Remember when we had compound events? Compound events means I'm going to pull a king and then I'm going to pull a queen. 2 events are happening. That's why you need to multiply it. This, even though we're talking about 2 things, only one thing's happening. Either I'm pulling a king or I'm pulling a queen. I don't get to pull twice. It is one pull. The other way to think about it is if I'm pulling a king or a queen, that's 8 total cards. So I should get down to 8 over 52, which I do. And we did that as the homework. We talked about that in the homework too. So or is still just one event happening. We just kind of have to add what happens when I add another card into that or statement. So or is adding and is multiplying. All right, next one says find the probability of drawing a king or a spade. Exclusive or inclusive? Yeah.
Inclusive.
Inclusive. Why?
Because you can get a king of spades or a king of spades.
Yep. So we can get a king of spades, so it means it is automatically inclusive. Both categories share something in common, and that is the king of spaders. All right, king of spades. So it is inclusive. Inclusive tells me I'm going to add the two probabilities together and subtract any overlap. So I need to calculate the probability of pulling a king or the probability of pulling a spade, and I need to subtract the overlap, which would be the probability of getting a king of spades. I was going to draw a picture, but it just turns terrible, so I'll just try to... There we go. King of spades. It got it on there. All right, the probability of pulling a king is going to be, well, there's 4 kings in a deck, so that's 4 over 52. Or tells me to add. Spades, there's 4 suits, so you could put 1 over 4. But since my common denominator is 52, I'm just going to put 13 over 52. There's 13 of each suit. And then we're going to subtract the probability of getting that king of spades, which is just, there's just 1 king of spades divided by that 52. That's going to equal 4 plus 13 is 17, minus 1 is 16 over 52, which 4 goes into 16 4 times. 4 goes into 52 13 times. We have 4 over 13. Do not forget to subtract the overlap. Otherwise, you counted that king twice. You're basically saying I could pull a king of spades and I can pull a king of spades, which doesn't make any sense, right? There, it's a standard deck. It says right there. I have boardage. Questions on that? Does that make sense, though? And you should be thinking inclusive, exclusive, or is that statement that tells you start thinking about that? The next one says, in a group of students, 60% are commuters, 50% are female, 30% are female commuters. Right when I read female commuters, I'm thinking we are talking about...
Us.
No. I'm immediately thinking either it's inclusive or it's exclusive because they're specifying groups. Well, let's just double check. So it says find the probability that the randomly selected student is either female or is that keyword commuter. So now I have to decide, is it inclusive or exclusive? And who can tell me whether it's inclusive or exclusive? Yes, it is inclusive. It is inclusive because they specifically told me there's overlap. 30% are female and 30% are also are commuters. So that is inclusive. So I need to find the probability that I get female. And I have to add the probability that it's a commuter. Let me put or in there, because you can put plus. I'm just going to put or for right now. Or it's a commuter. And we have to subtract away any overlap, which would be the probability of you having a female commuter, or the good old FC. All right, probability of it being a female. Since they gave me percents, I'll probably just leave it as percents. Because like I said, we usually use fractions, but if I give you percents, just leave it as a percent. Or if you change it into a fraction, you are okay as well. But the probability of being a female is 50%. Or tells me to add. Probability of being a commuter is 60%. If right now, if you would stop right now and do 50 plus 60%, you'd come up with 110%. If you ever come up with 110% on your probability, you did something wrong. So it right there would tell me, oh, I missed the problem. I needed to subtract something. It says subtract the probability of the overlaps, which are our female commuters. That is that 30%. So we're going to subtract 30%. That's the overlap. We're going to come up with 80%, or 8 over 10, or 4 over 5 if you used fractions. 80%, good answer, because I gave you percents to start off with. Yes?
What was your question to which I replied a plus? I forgot what it was.
I said, what do I think about when I see it says female commuters? You're like, a bus.
Okay.
All right, our next question says, when a pair of dice is rolled, dice are tricky. Dice are tricky with inclusive, exclusive, because if I change these numbers, it changes the entire problem. This one says, find the probability of the sum of 12 or, let me circle that or, because or means I'm looking for inclusive, exclusive, and I'll be adding. So sum of 12 or at least one die is a 2. Is it inclusive or exclusive? Catherine?
Inclusive.
It is inclusive. Why is it inclusive?
Because like the way I learned about it is like you have to do the probability of like the first like combination of twos, like where one like the first die has a 2 on it, and then where the second die has a 2 on it, and then also the one where the sum equals 12.
Oh, so you treated it a little bit differently than I did. So as you describe it, it would be inclusive. But as it's written, it is actually exclusive.
Wait, what?
As written, it's actually exclusive. Let me write it down and tell you why it's exclusive.
It works out to be exclusive, yeah. Oh yeah,
How many ways are there to get to a sum of 12? Yes.
1,
And what is it?
6, and 6.
Is there a 2 in 6 and 6?
No.
Is there any overlap between the sum being 12 and me having to roll a 2?
There's no probability.
There's a probability, but there's no overlap, right? Exclusive. This is, in fact, exclusive. I'm going to change it up in just a second. No sum involves 2. Before I continue, I'm going to change it real quick. We're not going to continue with these numbers, but I'm going to hypothetically say, what if I said instead of sum is 12, I said the sum is 6. Now is there overlap?
Yeah.
Nick?
Very much.
Very much, because you'd have 2 and 4, and 4 and 2 would be our overlaps. So be very careful when you read these. If I would say the sum equaled 6, you would have overlap. You would have 2 and 4, and 4 and 2 would be shared items. However, I said 12, there is no overlap, so we just need to find the probability of a sum 12. The probability of sum 12 is just 1 out of 36. It's a 6 and a 6, and we have 36 total possibilities. Then our next thing is at least one die showing a 2. I'm just going to put, or the 2 thing. It's just shorter than putting the at least 1, 2. I'm just going to put the 2 thing. Sounds cool. If I didn't have all these written out, I would kind of have to do that thing where I calculate what's the chance of not getting any 2s. But since I have it all written out, and this is what Catherine is talking about it being, she's talking about this one section being inclusive, is because this is 1, 2, 3, 4, 5, 6. If I counted down here and said this is 1, 2, 3, 4, 5, 6, and I said 12 of them, you'd be wrong, because there's 11 of them. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what you're talking about as being the... but if we're just counting, I'm just going to leave it as... Otherwise, we'd talk about exclusive and inclusive in the... So I'm just going to stick with 11 over 36, which is going to equal... I think I'm going to say it right this time. 12 over 36, which equals 1/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you circle them all the way that way, that's how you get 12. But if you circle each one individually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, cool. All right, let's speed things up because we got till 55. All right, we should be able to get through everything. All right, complement. Complement is what we started off talking about with that question about those red marble/cards, however I was saying it. So we're going to use a complement. And what a complement is a complement of event A. All outcomes are not the event A. So that's what a complement is all the outcomes that are not the event A, which would be A prime. In some cases, finding the complement is easier to calculate. Let's just do an example so we can see what the complement means. So we are throwing 2 dice. What is the probability that the 2 scores are different? In other words, what's the probability of getting a 1, 2, a 2, 3, a 4, 7? Nope, 6, because we only have 6 sides on the dice. Well, it's going to be really hard to calculate what they gave me. So instead, I am going to calculate the complement. I'm going to calculate the complement first. Let me make sure I write this the same way. Yes?
I had to take guess what the answer is.
Sure.
Is it 5/6?
Yes. Because it's pretty easy to calculate the opposite, right? So we're going to first calculate the complement.
Oh, you're sneaky.
And it doesn't have an I and it has an E in it. Yours should have an E up here. I don't know why. Do you see how mine has an I in it?
Yeah, ours has an E.
Mine, when I put it into this program, it automatically corrects it to an I. It should be an E. And so when I'm looking at it, I write an I all the time. Okay, our complement, which I'm going to let my complement stand for A prime. If my event is the 2 scores are different, my complement is going to be, what if they're the same? Same numbers. And the probability of it being the same numbers are, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There's 6 that have the same number, 6 possible rolls. We have 36 total rolls. So my complement is going to be 1 over 6. That is my complement. We have a 1 in 6 chance of rolling 2 dice that have the same numbers on them. That wasn't the question. The question is my original question, which would be P of A, and that would be different numbers. And this could be 1 minus our complement, which would be 1 over 6, or it's just pretty easy to see that it's 5 over 6. So you have a 5 in 6 chance of rolling 2 different numbers, and that's based upon the fact that I have a 1 in 6 chance of rolling same numbers. Does that make sense? Because sometimes complement can be tricky. A key that you're using complements is usually when it says like at least, or if it's super easy to just do the opposite. If you're really struggling on something, just ask yourself, could I do the complement? So like Luke, you did this really quick in your head, right? If you try to go the other way and actually calculate this first, it'd have been really hard, right? So if it's super hard, if you're thinking about all these different combinations, just think maybe the complement's going to be the correct way to go. All right, our next example of a complement is the letters of the alphabet are written on 26 cards and put into a bowl. No, these are just somewhere. 2 cards are chosen at random without replacement. What is the probability at least? At least 1 is usually a good sign that you are doing the complement. So the cards are chosen at random, and what is the probability at least one of them is a consonant? Well, there's a bunch of those.
Are we counting Y as a consonant or
Yes.
a vowel?
We're going to count it as a consonant. Okay, but
Nerdy question you could ask right now.
no. There's a whole bunch of them. So an easier way might be just to calculate what's the probability of I just get vowels. So we are going to do the complement first. So that would be P A prime, and that would be both vowels. Well, we're not counting Y. So we only have A, E, I, O, U, not Y. So we have 5 out of 26 for the first pull. I want to pull a vowel in the next one. What's the probability of pulling a vowel in the next one? Jack?
4 out of 25.
4 out of 25. It's 4 out of 25 because 1 vowel is missing. And what does that come out to? Something big. Let me just shortcut it. You should get 20 over 650, which simplifies down to, let me write it, 20 over 650, which simplifies down to 2 over 65. So that right there is the probability that both of them are vowels. So that's my complement. So my event that I wanted, at least one consonant. Will equal 1 minus 2 over 65, but sometimes it's just easy to picture it 63 over 65. It really is, what do I have to add to the numerator to get me to my denominator? That's 63 plus 2 would give me that 65 over 65. We good on that? Those don't pop up a ton, but they're important to know. It is the only way to solve some of these. All right, especially these at least ones. These at least ones, without this, we'd have to go into a crazy combination ones and permutations, which we're not talking about. So we have to know how to do the complement. All right, the last thing we're going to talk about are odds. Our odds. We probably have all seen odds somewhere, whether we're betting people. Hopefully none of you are, since none of you are of the legal betting age. But you might have heard, like, just reading articles, like you have a 6 to 1 chance to win, you have a 1 to 20 chance to lose or something. But these odds, 6 to 1, 10 to 2, are numbers that are thrown on a lot, especially around sports, when you're looking at which team is going to win in horse racing and anything of the like. Well, the problem is not many people know what those actually mean. They know approximately what they mean, but they actually get it wrong most of the time. First of all, when you're talking about odds, odds in favor and odds against are important to read. Those are important. They're going to change the direction of your odds. Odds in favor are defined as the ratio of the event happening to the event not happening. Odds against are the event not happening to the event actually happening. What I kind of look at it as win-lose. Odds in favor are my wins versus losing. My odds against are how many times I would lose versus how many times I would win. All right. Be careful here, because if you look at none of these say are possible outcomes. You will not actually have your possible outcomes in your odds. And let me show you what I mean by that. So our first example, example 6, says, what are the odds in favor of getting a sum of 5 when rolling a pair of dice? It also asks for what are the odds against. So the first thing I'm going to do is I'm going to get my probabilities. My probability of getting a sum of 5 is going to equal, we have 1, 4, 4, 1, 2, 3, and 3, 2. There are 4 different ways to get a sum of 5 with 2 dice. So that is going to be 4 over 36 is going to be my probability. So that's going to be 1 over 9. If this is my probability of getting my event, the probability against it is going to be 8 over 9. That is my probability that I do not get this. So if this is 1 over 9, the probability not happening would be 8 over 9. Now let's go to our odds. Let's do odds in favor first. In favor, we're going to take this 1. I will get this 1 time. In favor, I'm going to do what wins first. So that's 1. And there'll be 2, how many times I wouldn't get it. So that'd actually be 8 and not 9. 1 to 8. This is how many times I succeed. I would succeed once. But I would fail, let's just call it win-loss. I'd win once. I would fail 8 times. Against would just be how many times I fail. 8. to how many times I would succeed, which would be 1. All right, so that's what odds are. It's how many times you'd fail versus how many times you'd succeed. And we put a 2 between them. All right, let's go the other direction. This one says the odds of hitting a single number in a roulette are 37 to 1 against. What is the probability of winning in percent? So real quick, I'm going to write the odds down real quick. So my odds say I am 37 to 1 inclined to fail. So let's do the probability underneath it. My probability of actually winning would be I have 1 chance to win, because this is my fail to win ratio, because it is against. This is fail. This is success. Maybe I'll write that down. This is my fail. This is my success. So I can win once out of, would I put 37 underneath it? Are we okay with 37 down there?
No.
Jack?
38.
It'd be 38, because you actually have to do 37 plus 1, because you need to have your total possible outcomes. So it would be 1 over 38. This would be one of those tricky problems I probably wouldn't even take any points off on, because I do say what is the percent, and that percent would be about 2.6%. All right, and that is class. Have a wonderful, wonderful Thursday.